Let's stop it, okay? Beautiful. Yeah. Yeah. Yeah, because we have the class, so we had, so let's breathe some fresh air, then listen to the softer music. And Michael, I'm really admire him because sometimes when I was a student, I feel upset. I listen several times of his songs like Beat and Heal the World. And he's a dancer, right? And really amazing. He's so I think King of Pop. Yes. Okay. Yeah, the class question, right? So let's begin our today class. The next time, I think we can share other some music. It's no problem. No problem. Yeah. And tomorrow is National Day, right? And holiday, 7 days free. So yeah. Do you plan to go somewhere? Yes. Where? That's great. Yeah, 温州的桑阳 Westland, you know, 桑阳 Westland. Yeah, and Wuma Street, right? Boring? You think it's boring? Been there. Mountain. Yandan Mountain. Oh, in the National Day holiday? Yeah. With your friend? So, mountains are really hard. It's hard for some kid like me because of that, right? So really hard to climb the mountain. Yeah. But it's okay. It's okay. Yeah. And you know, go outside. Many Chinese people they talk used to Chinese, so if you do that Chinese, you will be easy, right? Easy and it is. Good at Chinese. Okay. So you go somewhere you bring him, right? Bring him. So he can join the travel free because I can translate, right? Oh. So okay. So yeah, talk about what we learned before, and at the first part of our class today, and the last class in the previous class, I think I introduced three strengths, right? Three strengths: the cubic compressive strength, and the prism compressive strength, and also a tensile strength. And for cubic prism, it's for cubic is a grid for concrete. For us to clarify it. And for prism, we use this compressive stress in the structure design. Yes. And for tensile stress, we introduce three experiments. Right? Three experiments. The one is the axial tensile stress. We use the specimen look like this, and to directly give the tension in it and get the tension strength. And also a split cube test, right? So, split cube test. Yeah. We use the cube as a specimen and the same compressor test machine, but the difference is we give it the bars, metal bars, and it apply the force like scissors, and to get the tensile stress, and remember. We know here in the last class we watched a video, right?
is talk about the cylinder specimen and the theme. And what the different is the formula we use is different, right? And for this one we get also a tensile stress, tensile stress FST, right? The first is FT and FST, and another we use a beam. We can get tensile stress from the beam specimen, right? Yeah. There is your 2-point load on the beam, and another is a 1-point beam. And for use this type of specimen get the tensile stress, we use this formula, right? The formula, FR. So if we want to compare the concrete tensile stress, we can throw these 3 experiments on these 3 tests to get the tensile stress and compared which the concrete is better, right? In different grade concrete, different grade concrete. Okay. Yeah, that's the things which we learned last class, and here begin of this part, I want to summarize. Yeah, before what we introduced, just a character parameter that describe the concrete. Okay, I hope my student can remember this 3 strengths and how we can acquire the strengths for cubic and for prism and for tensile. And I introduced some tests to get this value, right? And these 3 important character parameter. Right? Now we begin the next part about the stress-strain relationship of the concrete. Okay? And the concrete, we know, just a stone, like a material obtained by permitting a proportion mixture of cement, sand, aggregate, and water. Right? These 4 important things they make together and get the concrete. Concrete belong to composite material. But I mentioned before, as engineer views, we can regard the concrete as a uniform material for calculate, for analyze. But exactly it's a composite material, right? Okay, you can give me any response, so we'll be okay. Yeah. Yeah, here I introduced how we get stress strain, the relationship. Before we mentioned, we use a cubic under the compressions test machine, right? Like the machine. This is a cubic. And there's a machine. And if we give the force, and the test the force divide area, we can get the stress, right? Or we use the P. Yeah, from the machines, one side, we record the values, the force, and also we test string. Strings, we know the deformation, right? Divide the size, the length. The cubic, the size is L. And if we give the load, it has a deformation. We use the symbol D to represent. And from the formula, the D divide L. L is the original the size of the spaceman, yeah, and the string, right? String. Yeah. Through the machine and through the test load, we can use this formula. Yeah, this formula gets stress, and according to this formula, we get string. And during the process, right? During the process, the values will decrease, will increase, and draw this line. Okay, and I remember before, maybe in teacher's Wu's class, he talked about stress strain curve about steel material, right? Steel material. Before I remember I asked you the question. Right? Do you remember this line, this curve? Yeah, this is about steel. And here, this curve is about concrete, okay? Did the teacher Wu talk about the concrete stress strain curve? No, he only talked the steel, right? Because he did the steel structure, and this class is the concrete, right? Concrete. And so now we know this curve, how we get. So let's analyze the curve and can know some interesting things. For here, the elastic deformation of a crystal, we know before in the microscope view, yeah. It's correct or not? Right. Yeah, microscope view. Okay, I show you. Yeah, in here, look at these features, right? This is the microscope view to see the concrete. Right or not? That's right. Okay. Yeah. So this is the detail, right? Details, and we give the force. This force not really large, only small, right? Small load applied to the concrete. Here's yeah. There's elastic. I think you can distinguish the elastic and plastic, right? Elastic, it may introduce in the material mechanism. Yeah. The elastic means if we apply the load, it has the deformation, and we remove the load, it can go back, right? It can recover, right? Recovery back. So, and in this period, in this stage, 0 to A, because now it's the elastic deformation of a crystal. How to say? Just look at here. They may have to, because before I mentioned there is a micro cracks already exist between the aggregate and some crystal, right? If we give the load, there's will crack, will touch, and if we remove the load, it will go back. These things will not affect the material. This only is a elastic. Okay. Here, because can explain by that already had a really minimum cracks already exist between the aggregate and the GU, and we plot the load, the crack will touch, but do not affect other things, and then we remove it, the crack go back. So this deformation in this period, it means the elastic period can, we apply the load, it can recover and can go back. Can you understand? 可以恢复的，弹性的，恢复的。In this period, when load is really small, not so big, so large. Okay. And the next, when we increase the load, look at here the stress increase. Same, the P increased. And in here means that GU and the micro crack developed. The GU touched the aggregate. Before we think there's already the cracks, the GU do not touch the aggregate, the cement, right? Cementation. Okay. Cementation, right? This is the geo, this is the aggregate. Before, in the first page, this had the cracks. They touch and they can go back. Will do not affect exactly this ingredient. But when the load applied it increased, they touched and affect. It's already the materials. So the curve we obtain is nonlinear. Yeah, nonlinear. Okay, the nonlinear. And the next in the third, the value increase. Because we know if we give the force in this direction, the length will decrease, right? It means it had a deformation. But in this direction, it will be bigger, right? Bigger. So totally here we see the volume exactly it increase because it's affected by the load applied on the specimen. There has some characters phenomenon, interesting phenomenon, and then the concrete peeled out. They do not on the cubic. The figures will look like this. Right? This concrete peeled. So this is the descending branch. Yeah, descending branch. Okay. So from this curve, we can know how the concrete under the compression is developed under the from the stress strain, and we can explain something about the concrete under the load, how its behavior will look like. Yes. Here I just roughly to mention that we can divide there's a 1 to 3 stage. In the third stage, unstable development of crack materials sorting phase, because in this period the aggregate will destroy the cementation, and before the cementation, after hydration process, the cementation has his own shape, his own some stiffness like that, because it also cementation can resist the load. It do not affected by the aggregate, but that's why in the first stage, the cementation and aggregate, they do not attack because there has already the cracks exist on the surface of this true material. But if we give the load, we increase the load, they attached, and in the third, they affected each other, they coupled together. The aggregate has strong the stiffness, they will destroy the cementation, right? Because cementation is a softer thing, he is weaker than the aggregate. So these two ingredients affect each other. Okay. Yeah, and this is about talk about the deformation. This is the longitudinal strain. That means under the compression, the strain is described in this direction, vertical direction, and the transverse strain is in the horizontal direction. Yes, they measure together, and from this formula can describe the volumetric strain. Yeah, and they measured in 0 to 8, right? 0 to 8 in the first period one. They are elastic. That means it had the deformation, had the strain. It's under the load, had the stress. They can come back, they can recover. But in this period, from this formula, the volumetric strain is increased because in the transverse had the two, right? They had the two sides. That means in this side and in another side. So yes, yeah. In the transverse, in one side is small than the longitudinal strain, but they had the two sides, so they together exactly means the volumetric strain increase from this curve. Okay, and later in the third period, they increased, but some concrete peeled out, peeled from the concrete, cubic, yeah, peeled. So the volumetric strain, they decrease. And from this phenomenon, we can know, right? We can explain if the concrete, it be refined. Look at here, confined. If it can confine concrete, can increase the concrete strength. Means if we give the force in transverse direction, means we to put the transverse strain now the transverse strain is a negative, right? Negative. If we give the force to this is the transverse strain. So this curve, the volumetric strain, will be it can resist the larger the deformation of the concrete. So the stress of the concrete can bear the larger the load. Yeah, here is a complicated because you need to know the principle of the concrete, how it developed under the load, right? Because here we introduced in the microscope view to explain why how the concrete bear the load, how it developed, how it broke. But for student, for you, just need to know the here or like this. You need to know this is the curve can divide 3 stage, and in different stage they have which the phenomena you know it will be okay, and know the conclusion that scientists they do this research and they draw the conclusion. And for students, you need to know the conclusion that will be okay. Maybe the process, how to explain or how to tell other people the reason they not needed, not necessary. Okay, but I introduced here just so that students to know it for easy to understand. Right? Yeah, for confined. So sometimes we use a steel tube, and pull the concrete in the tube. Yeah, so it can increase the concrete strength. Or this from this curve can explain that. Yes, here we explain this curve in detail because now we know in 0 to 8 they are elastic stage period. So there's look at the word here before the A point, they belong to the first stage, right? There's no significant development into cracks. Yeah, because before they already the really small, really minimum, the cracks already be there, right? Be there. So in this period, there's no significant development in the micro crack. The deformation of the concrete is mainly elastic. Yeah, not in this period we regard concrete as a uniform material, right? The stress strain relationship approximately be linear. Yeah, the linear. And for, yeah, here I ask the question, normal, how we distinguish the normal concrete or the high strength concrete here? How? Who can tell me? In which range of the concrete belong to the normal? There is a critical value, right? Critical value. Y'all know? Chujiang?
I'm not sure, but C30
C30 to 50 is belong to normal, and higher than the 50 is the higher is the high strength. Yeah. Chujiang C is correct, because he mentioned the critical value C50. Yeah, C50 is a critical value. Okay, 0.5 scores. Okay, yeah. So here before I talked about the normal strength concrete and high strength concrete. They are C50, right? C50. C50 and the C50. Let's review C50. Before the C50, the prism and the cubic compressive stress, right? There is the cubic. This is the prism, right? Prism. The strength K. The coefficient will be different, right? Yeah. Do you remember? The C50 is around 0.7 and the C small. If higher than the C50, the coefficient may be 0.8, right? 8. And for now, for here, for normal concrete, that means the grade of a concrete below the C50. Yeah, the A point. Yeah, the A point, sigma A, stress A, means the critic of the elastic state. Elastic concrete state. They're around 0.3. FC means in the cubic strength, right? Cubic strength. About 0.3 to 0.4. For high stress strain concrete, the stress A point corresponding to 0.5 to 0.7. Yeah, this conclusion that drawn by the lots of experiment, the other scientists they do this type of research and to propose this formula. Okay, and for point B, we know 0 to A point, they are elastic state, right? For A to B, they are nonlinear state. But from the stage 2, we also know the stress on the string, they increased. When the stress increased, the string also increased. But the relationship is not linear. They are non-linear. Yeah. At point B, they have part of a plastic deformation produced, right? Because the aggregate, they taught cementations, okay? Here, I just draw part of the cementation with the aggregate, and in another, right, they also have some cracks. So come to B point, that means the plastic deformation exists during this period. The plastic means that we apply the load and remove it, the deformation will do not recover, right? Recover will yeah. Yes. So for years, they are gradually deviate from a straight line. They are now linear, and the sigma b, mean B point, according to this value, right? Sigma b, this is the sigma a. As a long-term compressive strength of concrete. For normal concrete, it's around 0.8 XB. And for high stress concrete, the value is 0.95. And look at the specimen here, we can see the cracks, the large cracks, and exist on the specimen, right? Okay, to here, I ask that student, do students have any questions? Yeah, if you have a question, you can say it, and we can discuss. You back? Okay. Okay. Yeah. Because here, the knowledge asked you may have a familiar about material mechanism, and also you need to know how to carry the experiment. So some students may feel it complicated, may feel, oh, it's really hard to understand. Yes, but I will try my best to explain that. Well, now the sigma A and the sigma B is about the stress, right? Stress, it's how the relationship to the cubic compressive stress. So let's, I think we can talk some easy things. Okay. So before, do you make the concrete in the laboratory? No? One time or no? Never. But I remember the senior, the higher, the senior, they tell me, sometimes you will have go the laboratory to watch to some machine and参观,参观 they have this experience. They go to our schools, college to see the laboratory, and they also go to North Campus. Yeah, there has a large laboratory, and there's a lot of machine. In this semester, do you have this class or not? No? Next? Maybe? Yeah, but now you are the senior, the grade 3, right? Grade 3. It's a time that you, it's time that you to talk to familiar about how exactly the concrete it is and how to make it and know it. Yeah, may do some experiment, you can familiar about exactly the curve.